Welcome back to the Gas Law channel. I'm going to stay awake for this. It is 6 p.m. Here we go. Here's a really fun problem that involves the ideal gas law and it involves mass. So both things that we suck at. Here we go. One of my students from my worst class, period 4, inhaled 600.0 milliliters of bromine gas because they misplaced their brain cells. Yeah, don't do that. It's not good for you. At 9.00 degrees Celsius and 314.2 kilopascals, what mass of bromine did my idiot inhale? Okay, let's take a look at this problem. I'm given a lot of information here. I'm given milliliters, that's a volume. I'm given bromine gas, which that'll come into play later. I am given a temperature, 9 degrees Celsius, and I'm given a pressure. So I'm given a pressure, I'm given a temperature, I'm given a volume. So I'm given three things and I'm missing one. I'm missing moles. But nothing is changing. I'm not saying that the pressure is going from one value to a new value. So because I'm only given one of each, we're going to use the ideal gas law. And how the heck are we going to get mass? Well, mass and moles are they're related a bit. So if we get the moles of bromine, we can get the mass. Ready? Here we go. So let's set up my PubNerd equation, PV equals nRT. So I'm going to set that up right now. PV equals nRT. Just like so. So there's a couple numbers we're going to need here. So in this equation, your pressure has to be in atmospheres no matter what if we use our R value. So here we go. Pressure is going to be 314.2 kilopascals, and we know that there are 101.3 kilopascals in an atmosphere. So now we are in atmospheres here. We know my volume too. However, volume has to be in liters for this equation. So 600.0 milliliters becomes 0.6 liters. We are going to include that there are 4 sig figs in this number. So you don't have to write them all out. As long as you know that there are 4 in your answer, you're good. Because we have 4 sig figs in every single one of these numbers. So here we go. My next number, I'm just going to write 0.6 liters. And how did I do that? Well, I took my 600 and I divided by 1,000. There are 1,000 milliliters in 1 liter, so this now becomes liters. Yay, atmospheres, liters. Let's put an equal sign in there. Here we go. Let's keep going. All right, now we have N. Well, N is what I'm solving for. I don't know that yet. Let's do R. R is 0.0821 liters atmospheres over mole Kelvin. Okay, this obnoxious unit just tells you that you need these units in the ideal gas law. That's about it. All right. Now there's one more thing we need. We need temperature. But temperature's in Celsius in this problem, not Kelvin. Uh-oh. Don't forget to convert. Do it. Do it. Convert it. All right. 9.000 degrees Celsius plus 273 should give you Kelvin. So here we go. 9 plus 273. Perfect. Now how the heck am I going to solve for this? All right, ready? If I want to isolate N, I'm going to do this division first. Then I'm going to multiply it by 0.6. And then to isolate N, I'm going to divide by this number. And then I'm going to divide by this product, 282. So this right here is 282. And we need to solve for N, so let's do it. I will take out my handy dandy calculator on my phone. Here we go. I have 314.2 divided by 101.3. Enter. Great. It's around pi. And then I'm going to add or multiply by 0.6. If you beat me, you get 100 on this test. Now I'm going to divide by 0.0821. Enter. Then I'm going to divide by 282. Enter. I'm getting 0.08038 8 moles. Yeah, 4 sig figs. Haha, sucker. All right, here we go. So I have N equals 0.0. My leadings don't count, so yeah, we ignore those. 8038 moles. Oh boy. All right, that's the moles. Now we know we're bromine gas and we're looking for mass. We're bromine gas and we're looking for mass. So here we go. Bring it on. All right, over here, I'm going to say my molar mass is mass over moles. So molar mass. Now bromine gas, keep in mind, is Br2 because I'm a diatomic gas. That's me, and I'm not going to test you on that. But don't forget that. So molar mass of Br2 is going to be grams per mole. Now, you have your moles, you have your molar mass. Br2 is around 80. So let me check here. Molar mass of bromine is 79.904. So we're going to take that and multiply it by 2. My molar mass is 159.808. So we're going to say 159.808. Now look, molar mass times moles should give us grams if we solve, right? We want to isolate grams, so multiply both sides by moles. So 159.908 multiplied by 0.08038. And here we go. Enter. 12.84 grams, 12.85 grams. That is a lot of grams of bromine. That student will miserably die and have a good night. All right. That's it for me. Peace.